All right, so all of these are going to go back to your slope-intercept form, okay? They're all going to go back to your slope-intercept form. So remember I said you're going to see this over and over and over and over. And so you want to drill into your brain your slope-intercept form, which was y equals mx plus b. Remember that m is your slope and that b is your y-intercept, okay? The number in front of your x is your slope. The constant is your y-intercept. Only in slope-intercept form, not in standard form, okay? So only in slope-intercept form is that hold true. So they have said, write the equation of the line with a slope of 2/3 and a y-intercept of 0, -5. Okay, they have given us our m and they have given us our b, right? So they've given both of those to us. And so we are legitimately just going to rewrite y equals mx plus b. We're going to plug in m and b. All right, that's simple. So I'm going to say y equals, instead of m, 2/3 x plus or minus. What is my y-intercept? -5. So I'm going to say -5. And that is my answer. Do not overthink it. That is my answer. Okay, so if they just hand you the slope and hand you the y-intercept and say, write the slope-intercept form of the equation, you literally just write the equation and plug in your m and b. That's as simple as that, okay? So that's really easy. That should be one that you just don't even have to think about, okay? The next example is a little bit different, all right? So the next example says, write the equation of the line passing through the point 1,5 with a slope of 3. Is 1,5 an intercept? How do I know it's not an intercept? It doesn't start with a 0, or it doesn't end with a 0. That would be my x-intercept. But 0 something is my y-intercept, okay? This guy is not a y-intercept. It is just a coordinate on my line. It is, however, an xy, all right? Why does that help me? I have an x and I have a y. What else do I have? They gave me something else. The slope. What does slope represent? Which one of those letters is slope represented by in my slope-intercept form? M. So they have given me an x, a y, and an m. Which one do I not know? Which variable up here in y equals mx plus b do I not know? I have an x, I have a y, and then I have an m. B. All right? I need an m and a b to be able to write my equation. I have 3 out of 4 variables. So all I'm going to do is plug in the 3 that I know and solve for the one that I don't know, okay? So my equation is y equals mx plus b. Excuse me. All right, and so I'm going to plug in my y. My y here is 5. I'm going to plug in my m. My m here is 3. I'm going to plug in my x. My x is 1, and I'm going to say plus b. And then I'm just going to solve, right? So I have 5 equals 3 plus b. I'm going to subtract my 3 over. B equals what? 2. All right. So now I have an m and I have a b. Now I can write my equation. My equation is going to be, remember, I only plug in my m and b when I'm plugging in for my equation. I leave the x and y as variables. This was just one of many x and y's, the 1, 5. So I'm going to say y equals m, that's my 3, x plus my b. And that is my equation for that particular line. So write the equation of the line passing through the point -5, 6 with a slope of -1/2. Once again, they've given us x, y, and m. So y, 6, equals m, -1/2, x, -5, plus b. This is the same concept. We're just using fractions. 6 equals, what's -1/2 times -5? Negative times a negative first is a positive. Remember, 5 is over 1. So 1 times 5, 2 times 1. All right? Plus b. How do I solve for b? How do I solve for b? What do I do? So you can if you want to. So if you wanted to get rid of those and then divide it back out, you can. I'm going to show you both ways. So you can just subtract your 5 halves if you want to. Minus 5 halves. Remember, this is 6 over 1. So what's my common denominator? 2. So times 2 times 2, that's going to give me 12 halves, right? Make sense? So you can do that. 12 halves minus 5 halves, you're going to get b equals 7 halves. Okay? If you want to get rid of your fractions, so let's say you're like, I don't like fractions. Let's get rid of my fractions here. You can multiply everything by that 2. You also have to multiply the b by the 2, okay? You're going to get 12 equals, this guy's going to cancel, 5 plus 2b. Subtract your 5, 7 equals 2b. And once again, b is going to equal 7 halves. Okay, so I don't care how you do it. You can keep the fraction and get common denominators. You can eliminate the fraction. Just make sure if you eliminate, you multiply every single piece of it by that denominator. Either way, we now have our m, right? So we have our m right here, and we have our b. So to write this equation, I am going to rewrite my y equals mx plus b, filling that in. Y, let's not do it in that, let's do it here. Y equals m, negative 1/2, x, plus b, 7 halves. Just leave it as a fraction, okay? Now, when you graph it, you may want to say, okay, 7 halves is 3.5, so I know that's between 3 and 4 on the y-axis, okay? So when you graph it, you may want to think mixed number, but you can just leave it as an improper fraction. That's perfectly fine, and that would be your answer. Y equals negative 1/2 x plus 7 halves. One more like this. Write the equation of the line passing through the point 1, negative 6 with a slope of 0. With a slope of 0, okay? So once again, I have an x, a y, and an m. Y equals 0 times 1 plus b. What is my b? 0 times 1 is 0. So negative 6 equals b, right? Yeah, that zeroes out. And then I just have negative 6 equals b. Everybody see that? So let's rewrite it in slope-intercept form. Y equals m, that's 0, times x plus, or in this case, minus 6. I'm not going to leave it that way. Why wouldn't I leave it that way? Because it says 0 times x. So what happens here? This is actually just 0. Y equals negative 6. This is a special line. What kind of line is this? It's special. Opposite. Horizontal, okay? Remember, y equals a number is just a horizontal line on the y-axis at negative 6. So we would go to, like if we had this, we'd go to negative 6 down here. Let's pretend that's negative 6. And we would just have our line right there.
So would there not be an m?
So the m is technically 0, but when you write it, there is no x that even shows up. If it had been x equals a number, that would have been a vertical line, okay? So when you have a slope of 0, I don't even have to go through this process. Whatever my y is, that is what my line is going to be. So if my slope is 0, my line is going to be y equals a number. And if I have any point on that line, it's just whatever the y value is of that point. Okay, because every y value of this line will be negative 6. You'll have negative 6, 1, or 1 negative 6, 2 negative 6, 3 negative 6. Every y value of this line will be negative 6. And so if I can see that my slope is 0, I don't have to go through this process. My equation is y equals whatever the y value is of the point they gave me. So on number 2, they gave us our m. What else did they give us? Our b, right? Our y-intercept. So you just literally had to plug that in. Y equals 4x minus 9. Okay? Y equals 4x minus 9. So we literally just had to take our equation, y equals mx plus b, and we plugged in our m and our b. Y equals mx plus b. That's just 0. That will always be your b anytime your x is 0. So you don't even have to go through the process of doing that. They've handed you your b when they've given you a number that has a coordinate that has a 0 as your x value.
But it will still be right if you were like...
So if it is asking for the equation, your x and y have to be left as variables. Remember the handout that I gave you? X and y are left as variables. So your answer, when it's in this form, the only two things that should be filled in are these two. Your x and y should still be an x and y because it represents a set of numbers that is a infinite line. So there's a ton of x and y's that appear on that line, not just that one. All right, let's look at the next one. All right, so for the next one, they gave us an x and a y, and they gave us our m. So we're going to say y equals mx plus b. Y equals mx plus b. In this case, they did not hand us our b. All right, so we are going to solve for it. So we're going to say 2 equals, what's 8 times negative 3? Negative 24 plus b. What do I do to solve here? Yeah, add my 24 to both sides. All right, so it's going to cancel here. 26 is going to be my b. So now I have my m and my b, and I just plug it in. Y equals m x plus b. All right, let's look at this one. Write the equation of the line passing through 1, 3, and 4, negative 2. They've actually given us 2 x's and 2 y's. We, however, do not have an m and we do not have a b. This is a problem. If I have to write the slope-intercept form of this equation, I need my m and my b, and they have not given me either, okay? They have, however, given me 2 points. I can solve for one of those using those 2 points. What can I solve for if I have 2 points? Yeah, the rise over run, which is also called the slope, all right? So you are going to use your slope formula to calculate your slope. So my slope formula is going to be y2 minus y1 over x2 minus x1. And I will solve for my slope. So I'm going to say, okay, this is going to be my first group. This is going to be my second group, all right? Or vice versa. It doesn't matter, all right? So if I want to solve for my slope or my m, I'm going to say y2 minus y1 over x2 minus x1. So I have negative 2 minus 3, that's negative 5. 4 minus 1 is positive 3. So my slope is negative 5/3. Okay, negative 5/3. Now I have a slope, and I actually have 2 x's and y's that I can choose from. You can use either. You can use either xy set to solve for your slope-intercept. You'll actually get the same exact number, no matter which point you choose, okay? So if one is easier than the other, then use that one. In this case, you have a 1 as your x. It may be easier to multiply your fraction by a 1. Neither one of those gets rid of your fraction. So let's say if one of those had been divisible by 3, like say I had 6 as an x, I may choose that one because that would eliminate my denominator, right? Do you see what I'm saying? Just like when you're picking your points to plot. But neither one of these actually gets rid of your fraction altogether. So I can just use this first one. And I can say, well, my y value is 3 equals m. I just solved for that. Negative 5/3 x. My x for that one is 1 plus b. So I have 3 equals negative 5/3 plus b. Again, you can do this either way. You can either get rid of your denominator by multiplying everything by 3 and then just redivide at the end, or you can use common denominators and add that over. So then how do I get rid of my fractions? My denominator is what? 3. So I need to multiply every single piece of this by 3. I'm going to multiply that by 3, this by 3, and my b by 3, okay? On the left, I have 3 times 3, which is 9. When I multiply this fraction by 3, I really just get rid of the denominator altogether. So I have negative 5 plus 3 times b is just 3b, right? Add my 5 over. So I have to add this over. All right. 9 plus 5 is 14 equals 3b. And when I divide by 3, I get b equals 14/3. I can't reduce it. I have b equals 14/3. Now, I have my m. That's what I solved for. I have my b. That's what I just solved for there. I can now write my equation. Y equals m. That's negative 5/3. X plus b. That is 14/3. And I have that in slope-intercept form. So when you're given 2 points, you're going to solve for your slope first, then use your slope in either one of your points to solve for your y-intercept. Then you're going to rewrite it in slope-intercept form. So if you're looking at steps on how to do this, right? Your first step is to use your points to solve for slope with your slope formula, okay? Then you're going to plug in your slope and a point to solve for your y-intercept, your b. And then your last thing is to just plug it into your slope-intercept form. Okay, so we're going to do that with the next one. Do that with the next one. It's a little bit different though, okay? So let's look at the next one. Write the equation of the line passing through the point 7, 4, 7, 2. All right? 7, 4, 7, 2. Do I know my slope yet? I don't. They did not give it to me. This is a special case though. Special case. I have x1, x2, y1, oh no, x, look at that. That's exactly what you don't want to do. y1, x2, y2, all right? y2 minus y1, that's 2 minus 4. x2 minus x1, that's 7 minus 7. What is 2 minus 4?
2.
Negative 2. What is 7 minus 7?
0.
What's the problem? If this had been a 0 on top, my slope would be 0, but a 0 on bottom is undefined. This is a special case. What type of line has an undefined slope, vertical or horizontal? Vertical. Vertical lines are which variable equals a number, x or y? Which was horizontal? We just did a horizontal and it was which number? Which variable?
Y.
It was y. So horizontal is y equals a number, all right? Vertical is x equals a number. What do you notice about the x's on these particular points? They are the same. So anytime you have 2 points that have the same number as either of the variables, it's going to be a special case. I have the same x's. This is going to be a special case. This is going to be x equals my x's, all right? When I had my y's were, and on the other equation here, we had 1, negative 6, right? And that ended up being, so let's say we had 3, negative 6. Let's say they gave us these 2 points. You should immediately notice that you have variables that are going to be the same. My y's are going to be the same for this one. I can stop right there with calculating. If I have 2 points that have the place settings like either x's or y's that have the same exact number, it's going to be a special case, okay? If my x's are the same, 7 and 7, my line is going to be x equals 7. If my y's are the same, negative 6, my line is going to look like this, okay? So when you're given 2 points, before you start, frantically figuring out slope, just double check and make sure that you don't have a special case. If you don't, then go ahead and calculate your slope. Use y equals mx plus b to calculate your b, okay? But if you see this, you don't even have to do it. You're going to get either a 0 or an undefined slope, and you're going to have a special case of x equals a number or y equals a number. And it's going to be either a vertical or a horizontal line, all right? Questions on the special case. Find the slope-intercept form of the equation given these 2 points. So this is a word problem, given us a graph is what it's done. The Planning Committee for the City of Brownsville uses census data to project the growth of the city, determine the estimated rate of growth, and write the function rule describing this population estimate, okay? So basically what they've given us is a set of points, all right? And so when you're looking at something like this, just like when you were calculating slope given a line, you probably want to pick two that are rather easy to see. And then from there, use your slope formula and use your y equals mx plus b. All right, now these are ginormous numbers. I'm not going to give you ones quite this big. But, all right, so if you look at this, they actually used 2010 and they used 2015, all right? I personally would have used different numbers because I feel like 2010 you have to estimate, but it is nicely in the center there, right? So they just estimated that it was exactly in the center, all right? So how does this help us? Okay, so this right here, this dot has an x and y value. My x value is the year 2010. So that is my x value here. My y value is 56,500. I have an x and a y, okay? Then they use 2015, all right? So again, I have an x value of 2015 and a y value of 59,000. Now you can use any 2 points on this graph and do this process, but they want us to determine the estimated rate of growth, write a function rule. They're just saying, write the linear equation in slope-intercept form. That's all they're saying with all of those words, okay? So what am I gonna do? Well, I have an x1, y1, x2, y2. y2 minus y1 over x2 minus x1, all right? Now it looks ginormous, but it really ends up being like 2,500 over 5, right? Which is just 500, all right? What does that tell me? 500 population, that's people, remember y is on top, people per, what is my x here? Years, right? So people per year. The growth rate is 500 people per year. What is that telling me, right? How many people we are adding to the population in this particular town per year, okay? Then they want me to figure out what does that mean so they can maybe project going forward. You could calculate your y-intercept here if you wanted to. They actually go in and what do they do? It must be in a different set. So they used which one? So they just chose this first point here and put it in slope-intercept form. Y, well, my y is 56,500 equals my m, that's 500. My x, that's 2010 plus b. And they get this humongous number. 1,000,000, right, something like that. And then subtract it over. So they got a y-intercept of negative 948,500. Again, I'm not going to give you numbers this big, but y equals exactly like we figured. This is my m, x, it's a minus b, all right? Y equals mx plus b. So when they give you this random word problem in a chart, they've literally just given you a set of points. Find the slope, plug it into your y equals mx plus b to find your b. All right, question?